Scientific notation, part 1. Scientific notation is used when representing really large or really small numbers. Now there's two main parts in any scientific notation form. The first part is this part right here. That's 3.067. That's a number that's less than 10, but 1 or greater. And the second part is a power of 10 times the power of 10. Now these are the two factors, remember factors means multiplication, that are a part of any scientific notation form. So it's just this times this. And the reason why we do this is sometimes we use very, very large numbers or very, very small numbers, and it's just easier to do that when you can go ahead and represent things by a power of 10. For example, there's one chemistry thing that's used frequently that is 6.02 times 10 to the 23rd power. It's called Avogadro's number. And the thing about that is that that would be really a long thing to write out every single time. So we don't do that, we just write it out like that. So the first factor is less than 10, as I said, but greater than or equal to 1. The second factor is an exponent that is a power of 10. To change a number to scientific notation, count how many spaces you need to move the decimal point to make the new number less than 10, but greater than or equal to 1. Then you write down the number you now have, and then write it as multiplied by a factor of 10, with the power being the number of places you move that decimal. So it's easier to understand once you actually see how it's done. If you look here, this problem right here, if you change this into scientific notation, how do you change this into scientific notation? Well, all you do is you put a decimal point right there. And you can't really do that, but you can rewrite it in scientific notation, so it's going to be 9.3. Okay, so if I go ahead and do that, if I wanted to do this, I'd have to go 1, 2, 3, 4, 5, 6, 7, 8 spaces over. So it's just going to be times 10 to the 8th power. And you can do this the reverse way where you count backwards, but some people I think just like putting the decimal point right there to begin with. So here, same thing. We're just going to put our decimal point right there, so let's rewrite it out. 3.123, 2. And now I count how many spaces over I go. I go 1, 2, 3, 4, 5, 6. So that's going to be times 10 to the 6th power. Now, the same thing works if you're taking a very small number. If we were to change this to a small number, how will we get that? It's going to be 5.23. 5.23 is going to be the number that's between, again, that number between 10 and equal to or greater than 1. Now here, we're making the number smaller. Now this time here, each time we're going to have we're multiplying by a power of 10, we're moving the decimal point over one space. It's the same thing here, except for you're moving it the opposite way, so you're sort of dividing by 10 each time. So the decimal point goes here. We go 1, 2, 3, 4, 5, and we are times 10 to the 5th. And so 1, 2, 3, 4, 5. It's going to be negative 5 because we're making the number, we're representing the number. It's a lot smaller than 5.23, so we have to indicate it that way. It's a lot larger, so this one here is a lot larger, so you have to multiply it by a positive power. That's it.